This lesson is going to look at how to generate a quadratic regression using the TI Nspire calculator. Make sure you write down your essential question, and when you're ready to continue, go ahead and restart the video. If you remember previously, we generated a linear regression with our calculators. And we found the correlation coefficient, and the correlation coefficient told us how closely the data, our equation, fit the equation that we got. Quadratic regression is more or less the same thing. It's just that our data is now representing a quadratic pattern, okay? And instead of having something called a correlation coefficient, we're going to have something called a coefficient of determination. If you remember that the correlation coefficient was represented with the variable r, the coefficient of determination is represented with r squared, which makes sense because quadratics have x squared in our equations. That's what the degree of 2 is what makes them quadratic. The closer to 1 that the coefficient of determination is, the better the equation models or fits our data. Okay, now here are the steps to help you work through your quadratic regression, but I want us to look at this example together. We're going to write our regression equation for this set of data. We're going to determine the coefficient of determination, and then we're going to actually look at what the whole purpose of generating that equation is. So if you will take your calculator, and if you will create a new document so that we're starting from scratch. So remember, anytime we want to enter a table, we're going to add a list and spreadsheet. So if you will add a page that says list and spreadsheet, and then we're going to enter our data. Now remember, you have to go all the way up to column A, and in our table it says T, which, I mean, we could label it T, but to make it easier for ourselves, we could label it T. Let's just label it X just to be safe. And then in column B, I'm going to make sure I go all the way up to the top, and I'm going to label that my Y. You can technically name them whatever you want. Okay, so in column A, I'm now going to input all of my values from my table. So if you'll take a minute and do that, I'm doing the same. Okay, once you enter your X values, then go over and up to the top for your Y values and enter all of your Y values. Okay, remember, it is important to make sure that your two columns line up, that you don't have extra numbers in one column or the next. And then I'm going to go over here to column C just because we want to make sure that our cursor is out of, a number box for sure. And so now what we need to do is we need to generate our quadratic regression. So we're going to go to Menu. We're going to choose Statistics. We're going to choose Stat Calculations. Sorry, this keeps auto-focusing. And so you see that you've got lots of different options, right? We've already done the linear regression before. Stop auto-focusing. But now we're going to do, sorry, let me focus. We're going to do the quadratic regression number 6. So pick number 6, quadratic regression. Remember, you have to choose from the drop-down menu X or Y, so we want it to be the X. And then for our Y list, obviously we want it to be Y because that's what we named it. Everything else we're going to keep the same, and we're going to click OK. And so notice over here on our right-hand side, it has generated our regression equation. Now what I want you to see right here is this right here. It's showing you the equation formula. Notice this is in standard form. This is standard form of a quadratic. You can see how it's told us what A, B, and C are. Okay? And then down here we also have R squared. And that's good. Okay, that's it. It doesn't have the R. So, okay, so we're going to write our equation now. So it says our A value was 0.1019 and so forth. Let's just kind of make it a habit of rounding to the hundredths place. So we're going to say f of x or n of t if we want, or y equals 0.1 or 10 x squared. That's my A value, plus B, negative 1.43. Negative 1.43x, and then your C value, 9.43 if I'm rounding to my hundredths place. So there is the equation that models this data. This is the regression that models that data. My R squared, my coefficient of determination, is 0.96. And what does it tell us about the graph? Well, we said the closer it was to 1, the better the fit. So this tells us that the equation models the data well. The equation models the data well. It is a good fit, so because that's pretty close to 1. Okay, so then what's the whole point? The whole point of generating a quadratic regression is that so that we can make predictions with our data. So it says after 50 months, how many text messages will have been sent and received? So 50 months was our x value, okay? So I'm going to take this equation now, and we can do it a couple of different ways. We could type in the equation and pull up a table of values, but I'm going to just plug in 50. And then let me go back up. Here maybe I should have written just minus. So minus times, everywhere I see an x, I'm plugging in 50. And I'm going to take my calculator. I'm going to go to a calculator page. And I am going to input this. So I've got 0.1 times 50. Whoops, I typed that in wrong, didn't I? 0.1 times 50 squared minus 1.43 times 50 plus 9.43. So all I did was plug in my equation with the 50 to my calculator, and I get 187.93. So about 187.93 texts. If you're thinking, well, you can't get part of a text message, then you could round up to 188 texts. But we're just using the equation, plugging in our numbers to then make a prediction with our equation that we generated.